Welcome back, students. This is the session 2 from the playlist of oscillation. The topic is simple harmonic motion, and I will be taking 3 sessions on this topic. So this is the first session, that is the session number 2 is the first session of this topic, and I will be taking the session number 3 and the session number 4 on this topic, that is the simple harmonic motion. So for this purpose, I have written here 3 bullet points. So today I will be describing this simple harmonic motion in brief. The first point is basically the definition of the simple harmonic motion, which states that it is an oscillatory motion in which an object moves back and forth about a mean position. So let us say a very good example of it is let us say this is a pendulum, and so if I displace it from its, this is the mean position. What is the mean position? The mean position is that position which can also be termed as the position of equilibrium, and at this position the net force acting on this object is 0. So if this object is displaced from its mean position, then it will start moving in this direction, then it will reach one extreme end, and from after that it will come back to its mean position, and again it will move on the other towards the other extreme. So in this way it will keep on oscillating about this mean position. So this is an example of the oscillatory motion, and here in this type of a motion the displacement, velocity and acceleration of an object is varying with the time. Here the object moves between the two extreme ends about the mean position, as I have already indicated here. Now in the simple harmonic motion, the simple harmonic motion can be the linear simple harmonic motion or the angular simple harmonic motion. In the linear simple harmonic motion, the restoring F is the restoring force. So this restoring force is directly proportional to the displacement of this object, and here this minus sign indicates that this restoring force, the direction of this restoring force is opposite to the direction of this displacement. Let us say this object is getting displaced from this mean position towards this extreme end, then this displacement is happening in this direction. However, the restoring force will be acting in this direction, and it will try to bring this object towards its mean position. So since F is directly proportional to this displacement, therefore acceleration will be also proportional to displacement. And here the minus sign means that the direction of this restoring force or the acceleration is opposite to that of the displacement. Second point, the angular SHM, that is angular simple harmonic motion. So in this case, the torque is directly proportional to the angular displacement, or we can say this angular acceleration is directly proportional to angular displacement. Third point, now these are the few key terms which I have written here, which we will be discussing in detail in the subsequent sessions. So first point here is the mean position. So what is the mean position? Mean position, as I have just told you, it is the equilibrium position at which the net force acting on this object is 0. Second point, amplitude. The amplitude is the maximum displacement of this object during the oscillatory motion. Third point is phase. Phase, it is the state of the oscillating object with respect to displacement and direction of the oscillation. So I will be discussing about these terms in detail in the subsequent session. So in this session, I just wanted to give you a brief introduction about this simple harmonic motion. So these are the 3 important, or you can say important terms which we will be using while studying this topic of oscillation, and this topic of the simple harmonic motion. And so we have understood what is the mean position, what is the amplitude, and what is the phase. The fourth important point is the angular velocity. This is also called the angular frequency in the books, and this is denoted by omega, which is equal to 2 pi upon t, where t is a time period. So this can also be written as 2 pi f, where f is the frequency of oscillation. And the next important term is we have already discussed, that is the time period. So time period t, and this is equal to 1 by f, and this can also be written as t is equal to 2 pi upon omega. Now next important thing, the displacement of an object. The displacement of an object in the case of a simple harmonic motion, is given by y, that is equal to a sine omega t plus phi. Okay? Now this is a general equation which gives you the displacement of an object at any moment of time. So y is the displacement, a is the amplitude of the oscillation. Amplitude means it is the maximum displacement, into sine omega t plus phi, where phi is the phase constant, and this omega t plus phi, it is the phase angle at any moment of time. Okay? So a is the amplitude of the oscillation, y is the displacement, and this omega t plus phi is the phase angle at any moment of time. So this was a general description, or you can say a brief introduction about this simple harmonic motion. So in the next session, we will be discussing in detail about these key terms, and I will also be deriving the equation for the velocity and the acceleration of the this object which is executing the simple harmonic motion. So till then, have a nice day. Bye.